Hello, Algebra 2 Honors. I had a few questions in office hours. Some other students had questions, and I realized that maybe it would be worth me doing a little bit of an extra explanation on a few issues around absolute value equations and inequalities. And hopefully this will help you with your homework if necessary. This is an optional video. You don't have to watch it if the homework makes sense to you. Okay, so I just want to say something about the inequalities and equations you see on the side here. How do we handle absolute value in these cases? And how do we handle the logical or and? There's a couple ways you could do it. I'm going to show you, give you a little help on that. Okay, so to clarify something, and these are the notes that I passed out in class the other day, and we did some of this, but I'm going to add some more here. We summarized that whenever you have the absolute value of some stuff in here, can be in anything in there. Whenever you have the absolute value of stuff is less than a number, and a would be a positive number, then you can rewrite this in two cases. Or you can rewrite this using a compound inequality. And what it means is, well, there's two ways to write it. You can write it as the stuff, whatever that is greater than negative a, and the stuff must be less than positive a. Now, what we'll often do is we'll combine the two together logically, and we'll just write an inequality where we put the stuff here. So that stuff that was on the inside is greater than negative a and less than positive a. So if I went back and made this, if I made this an expression like, 3x minus 5, then that would mean 3x minus 5 is greater than negative a, 3x minus 5 is less than positive a, and that thus 3x minus 5 would be squeezed in between negative a and positive a. And the other one we had was, for example, what if I had absolute value of 3x minus 5 is greater than a? Then we would break it up into two with an or. So that would mean that 3x minus 5 is greater than positive a, or 3x minus 5 is less than negative a. Okay, so those are the rules that really help with the inequalities, and there's also two cases when it's an equation. So this summarizes the inequality facts we needed to know. Now, how do we just work through some examples? We looked at two ways to do this problem. One was to do it algebraically, and that is to consider two cases. If I have the absolute value of something equals a number, then either that number equals a or that number equals negative a. That's the thing to remember. So in this case, what would that mean? That would mean that 1 minus 2x is equal to 4. Or we have the case 1 minus 2x is equal to negative 4. And now it's just a matter of solving for those values. 2x, x equals negative 3 halves. Okay. And the other case would be just 5 equals 2x. So I get x equals 5 over 2. So we get two solutions. And the absolute value gives us two possibilities. The stuff inside is either negative or the stuff inside is positive. We also learned a graphical way to do this by rewriting the inequality in the form. I'll write it over here on the side. We want to rewrite the inequality in the form absolute value of x minus the center, I'll put C for center, equals the radius. Okay, so how can we do that? We'll do this one in blue. I start out with this, absolute value of 1 minus 2x equals 4. We learned the property that when there's subtraction inside the absolute value, you can change the order of it. That was one of our facts we learned on the first day. And I can factor out a 2 inside the absolute value. That would be 1/2 equals 4. And we have the property that the absolute value of a product is equal to the absolute value of each factor separately. And then you can multiply the result afterwards. But the absolute value of 2 is just 2 because it's positive. And we get x minus 1/2 absolute value equals 2 when we divide both sides by 2. So we learned that on the number line, the center would be at 1/2. That's C, the center. And the radius is 2. So we go to the right by 2. You add 2 to 1/2. And you subtract 2 from 1/2. And you get a point here and a point here. And those points will be exactly what we had here. It's 5/2 and -3/2. 1/2 plus 2 is 5/2, and 1/2 minus 2 is -3/2. So we get the exact same answers as the algebraic approach. Okay. Now, on the inequality, to do it algebraically, we would break it up using our rule that we just mentioned a moment ago. Absolute value of x minus 3 is less than 4. That means x minus 3 is less than +4 or greater than -4. Add 3 to everything, and we get -1 is less than x is less than 7. Okay. And great. And then the algebraic or the graphical approach would be that the center is 3, and we go right by 4 to 7, and we go left by 4 to -1, and the graph is everything in between. So we have this solution, we have the graph shown here, and the interval notation, which we also learned would be from -1 to 7. All right. If I switch the order of the inequality, then we can break it up into 2. So it'd be 3x plus 2 is greater than 4, or 3x plus 2 is less than -4. And we just get what? 3x is less than -6. X is less than -2. Or, and if we solve this one, I think we're going to get 2/3 is less than x. I know you can do that. I'll just get to the answer. Okay, and because we have 2 inequalities with an or, that means we keep both sets in their entirety. And I'll just go straight to the graph. The graph would be everything less than -2 and everything greater than 2/3. And it does not include those values, so we're graphing in everything to the left of -2 and everything to the right of 2/3. The interval notation would be -infinity to -2, not including 2, so parentheses, union everything from 2/3 to infinity. Interval notation, graph, inequality notation. These are 3 different ways to write the same answer. Okay, couple quick. So this is a bit of a repeat, so I'll skip these first 2, and you should try them, and I'll put the answers in the notes. They might be a good way for you to practice that. And I wanted to do 2. I'm going to skip the previous 2. So I'm going to do 2 here where how do we handle and an or? You'll see it below me on the list. How do we handle the logic? Well, notice what we have is we have a statement here and we have a statement here. And we can handle each one separately and then pull it all together. Okay, so on the right, on the one on the left, I'll do this one in blue. And what I'll do is I'll write it down. X plus 2 is greater than 1, or x plus 2 is less than negative 1. So that is the statement here. So I've turned this one into this or statement. And I will do this side in green. This one is negative 4 is less than or equal to x minus 1 is less than or equal to 4. We can now simplify these two sides separately, and it will help. So we get what? X is less than negative 3, or x is greater than negative 1. And let's put parentheses around that so we keep everything sort of organized. If I add 1 to everything, I get what? Negative 3 less than or equal to x less than or equal to 5. Okay. Now that I've simplified this as much as I can, this is pretty easy to graph. It's two parts going away from each other. And this one's going to be pretty easy to graph. So we'll graph them above the same number line. Now here's where you can use just a little bit of visual inspection. So we've got what? Negative 3. That's an important number. Negative 1. I'm just going to put 5 kind of out here. I know it's not perfectly spaced, but that's okay. It's close enough. Just to get the idea. In blue, this graph is everything less than negative 3. And I'm going to draw it kind of floating above the number line. Or everything greater than negative 1. The green set is everything from negative 3 up to 5 inclusive. So I'm coloring those in. Now all we need to do is handle the and. We want everything that's in the blue set and the green set. So any number in our final solution needs to be in both sets simultaneously. And you'll notice that this actually goes forever to the right. And you will see that any number that is between negative 1 and 5 is in both the green set and the blue set. 5 is in both sets. Negative 1 is not in both sets because it's not in the blue set. So our final solution set is everything from negative 1 up to 5 inclusive. And so our final answer is negative 1 to 5 in interval notation. Our book would write the set of all x values such that x is greater than negative 1, less than or equal to 5. And we need to be flexible on the different types of notation that are used. Okay, last little quick example is x less than 3. X less than 3 or x less than negative 1. That's already simplified. And this one would be x greater than 2. Yeah, x greater than 2 or x less than negative 2. So we got these two parts. We can actually just graph this right away. Let's see, I'll do the right-hand side in green and the left-hand side in blue. Here's the number line in black. The important numbers are negative 2, negative 1, 0, 1, 2, 3. And the blue set is everything less than 3. Oh, actually, we can logically think about this. I didn't even notice, but you see, we want all the numbers that are less than 3 or less than negative 1. Well, all the numbers that are less than 3 include all the numbers that are less than negative 1. So this is redundant. because if we were to graph everything less than 3, it would be this set. And if we graph everything less than -1, it would be this set. We want everything that's in one set or the other, or both. Well, everything in the bottom one is in the top one, so we can just get rid of this because it's redundant. So this top one just reduces to x is less than 3. And this one. Okay, the green set that I'll do on the right is everything less than -2, or everything greater than 2. In the middle, we have an and, so we want what's in both. And that would be everything less than -2, because the two graphs are overlapping over here. And we've got this little section here where it's overlapping from 2 to 3. Okay. So our final solution would be everything from -infinity up to -2, not inclusive, union everything from 2 to 3, not including the endpoints. Okay, so that gives you a few extra examples just in case this was giving you trouble, and I'll see you in class.